Okay, so again, the last part of 9.3, which is labeled hyperbolas, but in this section, they also have something called the rotation of the conic, which we're going to do today. So what's happening on these is that we're taking conics or points, which you're going to see in just a moment, and we're literally rotating them around our circle. So something for right now has always been like at my complete XY axis, and I would plot my points right, left, up, down, whatever it is from that. So the question today is, what would happen if I took that axis and I rotated it? And that's what you're going to see. There's two quick skills I want to review, like algebra skills, that will help us with today. And that's what happens when you multiply two opposite binomials, and what happens when you square a binomial. So if I had something like x plus y times x minus y, what happens when I multiply these out?
You get a trinomial.
What happens to that middle term though?
Oh, you get a 2.
Yeah, you're going to get a binomial. I'm going to get the difference of two squares, right? So if it's the complete opposites, if it's an x plus y and an x minus y, I could FOIL it out. Minus xy plus xy minus y squared. But these two will always cancel out, and I'll get the difference of two squares, right? So that only happens when they are the exact opposites. Same two terms, one gets a plus, one gets a minus. Then you've got what happens if it's squared. So if I have x plus y squared, I could literally do x plus y times x plus y. I could FOIL it out, x squared plus xy plus y squared, and I'd get x squared plus 2xy plus y squared. So the shortcut here is to square the first term, square the last term, and then double the product. So if I multiply these two together, I get xy, a positive xy, the sign's important, and then I'd multiply it times 2, so that middle term is 2xy. We're reviewing these skills because they're going to be built into a long process that we do today, and if you can remember those shortcuts, it makes it easier, okay? So let's say I had x plus 3y, and I wanted to square it. My first term would be what? X squared. My last term would be 9y squared. The middle term, which would be the double the product, right? So 3xy times 2, positive 6xy. If I changed it so that it was negative, how does it change my answer? X squared again. Positive 9y squared. Now the product is negative though, right? Mm-hmm. So if I did 2 times negative 3x, my middle term is negative 6xy. So the process I'm about to teach you today, not the first example, but the second one, is I'm telling you right now, it is long and it is tedious, especially when you get to the last one, which is how Monday's going to be. But it is the same steps on repeat. So if you follow along with me today and then you practice it tonight with the homework, you will be okay. If you just turned on your camera and then set your alarm and close your eyes again, good luck, my friends. So if today's the day, if there's a day in which you need to make sure you're engaged and paying attention, it is it. Again, a friendly reminder that if you're working towards your extra credit, today is a day of notes, so that your cameras need to be on while we work together. Okay, so the rotation of a conic happens with an xy term. Nothing we have had up to this point has had an xy term. There's been x squared, there's been x's, there's been y squared, there's been y's, but no xy term. When you introduce an xy term, it literally rotates your axis. We are going to eliminate that xy term by using the procedure called the rotation of the axis. And the objective is to rotate to rotate the x and y axes until they're parallel to the axis of the conic. The rotated axes are denoted as, that is an x prime, is how that's read. And when you type that into your answers on WebAssign, it will tell you to make it XP. So that's what it would look like. And then the y prime axis would be the yp on WebAssign. When you answer this question on Monday for the test, it will be on an answer sheet. So you'll just use the little x prime and the y prime. Which means I'm no longer using the x-axis, I'm using this rotated axis. So on the diagram that's there, you obviously have your normal axis that are x and y. And if I ask you to plot an ellipse or a hyperbola or a parabola or a circle on that axis, hopefully by now we're pretty good at that. So what's going to happen today is that we're going to say take that axis and actually rotate it. This one looks like it's about 30 degrees, okay, or pi over 6. And then draw your new hyperbola. So if I'm going to draw a hyperbola or an ellipse or whatever it's going to be on this rotated axis. So let's just say it was an ellipse. It would look like this, rotated. So we would literally take that axis and rotate it and then plot our points. And again, I'm going to walk you through this process, okay? But this is a brand new thing, so this is something you definitely need to make sure you're paying attention to. We're going to baby step our way there. This first one is just a point. So the x prime, y prime coordinate system has been rotated theta degrees from the x, y coordinate system. The coordinates of the point are given. Find the coordinates of the point in the rotated coordinate system. So the first thing I'm going to do is just draw, actually, I'll pull right in the x, y coordinate grid. So I'm going to plot this point on my normal coordinate grid. So the original point is 4, 0, which is here. Now it's saying take and rotate this axis 90 degrees. So if I were to take my x-axis, which is here, and rotate it 90 degrees, what does it look like?
Vertically with go to -4 or +4.
So we're rotating, we're always going to rotate the same direction as my unit circle. So a positive angle is going to go to the left. So if I took that and rotated it 90 degrees, it actually becomes the y-axis. But we're going to call this x prime. So we actually took and shifted it completely 90 degrees. Then my normal y-axis also gets shifted 90 degrees, which means my y-axis actually become the x-axis. So we basically just took and rotated this completely around. Now the easiest thing to do, let's see if it's going to let me do it, is actually rotate this as though that was my regular x and my regular y. Where is that coordinate point now? So it started 4, 0, right? That was my original point. I plotted 4, 0. Let me do it in this color. Right here. Then it says, now take and rotate these axes. So rotate the x 90 degrees, rotate the y 90 degrees. So then I put x prime there because that should be where my 0 is, to remind me that's where my 0 is. And I put the y prime to tell me that's usually at the top of my graph. Then you want to literally rotate it so that it moves like that is my normal graph. And how would you name that coordinate point? Pretend like x prime's there, y prime's not there. It's just a regular graph. What's the name of that? 0, -4.
Why does it go to negative?
Because it rotated it around. So the axis got rotated, but then we have to rotate it back to actually plot it.
You never mark 0 or 0, 4.
No. So we're marking for these kinds of questions, which you're not going to get. There's more of the graphs than there are this one, which is what we're going to go next. These kinds of questions, you want to plot your original ones. You want to rotate your axis, whatever it said to rotate them to. And then figure out on my new axis, what would that point be called? So let's say I did the same thing. Let's say theta is now 45 degrees. And I said the same point, 40. So I'm going to pull in a coordinate grid. I'm going to plot my 40. Now, what would a rotation of 45 degrees take me to?
So like halfway.
About halfway.
Quadrant.
So this becomes x prime, and this becomes y prime. Now take my graph and rotate it so it makes sense to my, now my shifted axes. What quadrant is that point in now? It's in the 4th quadrant, which means it's got a positive x and a negative y. It's actually halfway, so if I actually wanted the exact point, I would use my root 2's because it's my 45s. Okay, you won't have to find it exact when it's floating in the middle like that. I just want you to see what's happening. Does that make sense?
Yeah.
Okay. So now this is a positive x and a negative y because the direction that we moved it. What's more important, like I'm not going to test you on a single point. What's more important is you understand the rotation of the axis. What happens and how I'm rotating that axis, okay? Because this is the biggie. This is what we're going to do, okay? So for this, we are doing this in one that it's called a general second degree equation. It has, which it should look familiar because we did this yesterday with the classification, except yesterday we totally ignored the xy term, and this day is completely focused on it. That xy term is causing a rotation of the axis. So again, up till today, or actually up till classification yesterday, none of the graphs that we did had an xy term. That is what causes the rotation. So everything you see in the rotation is going to have the xy. So that xy, again, determines the axis shift, okay? I would ignore that second row completely because I'm going to teach you how to get to it. The 2 other and most important things on here is that this is how we're going to find theta, because we need to know what is the angle that it's being rotated to. That's the first thing you're going to determine. So the cotangent of 2 theta equals a minus c over b. Remember, a is what's in front of the x squared, c is what's in front of the y squared, and now we've got the b is what's in front of the xy. So the values of those coefficients are going to go into this formula. I'm going to get a number as a result from there, and that number has to be one of the cotangents on my unit circle, which means the result of this can only be 0, 1, root 3 over 3, or undefined. So there's a short list of what that can result in. From there, you'll figure out which angle that is. So you need to know your cotangents or your tangents because we're going to flip them. And then at the very end, we're going to divide it all by 2 because 2 theta equals that. Then you get your angle. That's the first thing. So like if you're doing checkpoints in your head as we build, I would say your first checkpoint's the angle and it will earn you points. Then from there, you have to change x in your equation to be x prime cosine of that angle minus y prime sine of that angle. And you have to change y to be x prime sine of that angle plus y prime cosine of that angle. And then you will simplify your equation by figuring out what the sine and the cosine is at that angle. You'll work it out in its entirety, and at the end, it will be a conic. It will either be a parabola, a circle, an ellipse, or a hyperbola. You will then rotate your axis, and you will plot your conic. So these 2 things obviously need to go in your reference sheet. Three things.
I thought that was a 20, but I just realized.
It's 2 theta, yeah. I doubt myself, and before I get too far, sine plus cosine. We're going to start nice and easy. This says rotate the axis to eliminate the xy term in the equation xy minus 1 equals 0. Then write the equation in standard form and sketch its graph. So step 1 is find theta. Cotangent of 2 theta equals A minus C over B. What's the A in this equation? What's in front of the x squared? 0. What's the C, or what's in front of the y squared? 0. What's the B, which is in front of the xy? 1. So I get 0 over 1, which is what? 0. So cotangent of 2 theta equals 0. So you have two options. Either learn the cotangents in that first, and it's only in the first quadrant. That's all you're worried about. Learn them in the first quadrant, or flip it and use the tangents, okay? So if you remember your first quadrant, this would be 0, this would be pi over 6, this would be pi over 4, this would be pi over 3, this would be pi over 2. The coordinate points here, which, because we're going to need them, are this would be 1, 0, this would be root 3 over 2 and 1/2, this would be root 2 over 2 and root 2 over 2, this would be 1/2 root 3 over 2, and this is 0, 1. The tangents at those angles are 0, root 3 over 3, 1, root 3, and undefined. So I would say that also needs to go on your reference sheet. But we can, like if you go back to the notes that we started yesterday, there was a page for this, and I would add it in there. Okay, so my recommendation is flip it to become tangent, so you don't have to also know your cotangents. So this would mean that tangent of 2 theta would be the reciprocal of 0. What's the reciprocal of 0? Undefined, right? If I took this and flipped it, it would be undefined. So now go to your unit circle. What angle has tangent undefined? Pi over 2. But the theta doesn't equal pi over 2. 2 theta equals pi over 2.
Can you just repeat that sentence?
Theta itself doesn't equal pi over 2. If it just said tangent of theta equals undefined, then my answer is pi over 2. But because it says tangent of 2 theta, then I'm not at theta yet. 2 theta equals pi over 2. I have one more step, which is what? Divide by 2, or multiply by 1/2, and I get theta equals pi over 4. Now there's also a fixed set of how many answers can be there, because the result of theta has to be on my unit circle. So here's part 1. Figure out theta. A little bit of points. Not a lot, but a little. Okay. Now I have to take my equation and I have to plug in the place of x, and this is also on that last sheet. That would be on your reference sheet. In a normal year, that's the only thing of it you would get the whole chapter. Okay, so in place of my actual equation, the initial equation, everywhere there's an x goes x prime cosine, we know theta, it's pi over 4. Minus y prime, I don't know why I put the parentheses there, sine of pi over 4. Everywhere there's a y, I'm going to put x prime sine of pi over 4 plus y prime cosine pi over 4. Minus 1 equals 0, because that's the end of my equation. With me so far? So everywhere there was an x, we plugged in this with our value of theta, because we know that. And then everywhere there's a y, we plug in this with our value for theta, because we know that. Yep.
And you're multiplying both of them together?
Yeah, because it's x times y minus 1. So the original equation is what you're plugging it into, and it's going to change. Yeah. it's going to change. All right, so now think about what we know. What do we know about pi over 4? What's the coordinate point at pi over 4?
45 degrees.
That's my 45 degree angle. So it's root 2 over 2 and root 2 over 2, right? That means your cosine and your sine are both root 2 over 2. So I get x prime times root 2 over 2 minus y prime times root 2 over 2 times x prime times root 2 over 2 plus y prime times root 2 over 2.
You never get rid of the primes?
You can get rid of the primes. Like this time it's not as bad. Just wait till we get to the next example. I get rid of them while I'm working, but you have to bring them back because you have rotated your conic. You've changed it. It is no longer x and y. So as long as you remember to bring them back at the end, you can. You just got to remember to bring them back. All right, so it's super ugly, but what do you notice about those parentheses?
They're the same thing.
Minus the sign in between, yes? So we can use a shortcut to multiply those out. It's the difference of two squares, right? Yes? You with me? Does everybody see that? Because that's important to identify. Otherwise, you're doing a lot of extra work you don't need to do. So the rule on the difference of two squares is to square the first term. So the first term is x prime root 2 over 2. I'm going to put the number at the front this time. If I square root 2 over 2, what do I get? What's the square of the square root of 2? This would be 1/2, right? This would be 2 over 4, which is 1/2. So it's 1/2 x prime squared. Can't forget to square that. Then subtract from it, because it's the difference of two squares, the square of y prime root 2 over 2. So we're root 2 over 2 squared again, which again results in 1/2. So 1/2 y prime squared. So that was this whole thing. We multiplied out. There's still a minus 1 equals 0. Still with me? So think about the standard form of our equations in our conics. And what's wrong with where we're at right now? It has to equal 1. So we need to move the 1 to the other side. So this is really 1/2 x prime squared minus 1/2 y prime squared equals 1. I can even go a step further and say x prime squared over 2 minus y prime squared over 2 equals 1. What conic is this? It's a hyperbola. Yay. Right?
It was so much.
It's a rotated hyperbola. If it was the plus in the middle, what would you think it is?
An ellipse.
So it's an ellipse that has the same A and B, which makes it a circle. So be careful because you could see that, okay? If it was a plus, I'll say that again because I think that's kind of tricky. If it was a plus in the middle, it would appear as though it's an ellipse, but both A and B are the same, which would mean it's actually a circle. So with the circle, you would eliminate the denominator. I would multiply everything by 2. Or you make it an ellipse that goes the same distance up, down, right, left, and it doesn't matter. It will look like a circle, okay? But this is a hyperbola. So guess what, folks? We are now at step 2.
So that was step 1.
That was step 1. Well, step 1 was the equation. I just erased it, and now I can't undo it. Lovely. X.
I thought you said that was step 2.
This is step 1. This is step 2. Yeah, I mean the end result of step 2. That whole thing is step 2. The plugging in and simplifying is step 2. Now we gotta graph it.
So when you multiply the two terms together, you never get a middle term?
You can get, so what will happen is, I mean, a really bad one, you'd have to complete the square. Yeah, that's when it's really extreme. The other ones you'll see, like you'll see in the next one, it'll get a little bit worse. But if it has the x and the y, then you have to complete the square. And those are for sure the times I would say get rid of your x primes and put them back in at the end. Because I could have done it like without the x prime, just make sure at the end that when you put them back in. So the checkpoints on your test, the first one's going to say find theta. You did that. The second one's going to say find the equation in standard form, and that equation has to have primes in it. So that's what we just did. Third step is graph it. So I'm going to pull in a coordinate grid.
Oh, so that's what you meant by XP in the beginning.
Yeah, so in WebAssign, those little prime, those little apostrophes are actually going to be P's. So when you type that answer in on, and I think I gave you a multiple choice question where you have to match them to avoid a little bit of that, but then you have to do one that you'd have to write that as xp squared over 2 minus yp squared over 2 equals, this should be an equals, 1. That's how you'll type it in. I think I gave you one like that just so you can practice it. All right, so we have to rotate this axis, right? Pi over 4. We just did this with that last example, the one I added on, right? Pi over 4 is my diagonal through my first quadrant and my third quadrant, which means that my rotated axis is actually going to be here and here. This is your x prime, this is your y prime. So if you are doing this on a piece of paper, and you will, whether you're at home or you're here, I would physically take my paper and rotate it so that the x prime is where my x normally is. Oh, let me group this before I rotate it. Now I'm gonna actually graph my hyperbola on this red axis, not the original one. So tell me what you know about this hyperbola. A squared and b squared are both 2. So a is the square root of 2 and b is the square root of 2, which is like a 1.4, not even 1.3 probably, but we don't have to get that exact. What else do you know about it? What's the numerators tell you? Center 0, 0. Is it vertical or horizontal? Horizontal. So I'm going to start at 0, 0, because that's my center. I'm going to go right and left 1.4. Now these are not going to be pre-marked, so you're going to mark them, and whatever you mark them to be is what you mark them to be. Just be consistent. So if this is like a 1, 2, this would be a 1, 2, this would be a 1, 2, this would be a 1, 2. Again, you're marking that, so make them as consistent as you can. They don't have to be perfect. Because it's horizontal, I'm going to go right and left to get my vertices. I'm going to go up and down to get my co-vertices. I'm going to draw my box. I'm going to draw my asymptotes through the corners of this box. I would probably recommend like dashing them or making them different colors just so you know the difference. Oh, it's going straight through my thing. And then draw your branches. So when I turn my paper back the way that it was, your conic should be a rotated conic, which it is. It's not perfectly drawn, but you get the point.
How do you tell if it's horizontal if the weird shape?
It's always, remember this one, it's the first, for whatever's positive. So it's x minus y. And that's why if it was a plus, even though you could graph it as an ellipse, it would end up being a circle in the end. Because you'd go right, left, up, down the same. Everybody still doing okay? Ceiling fans are still moving. That's a good sign.
How'd you check this, make sure it was horizontal again?
The first term. So without the primes, right? If you wanted to write it without the primes so that it's easier for you to understand, it was x squared over 2 minus y squared over 2 equals 1. So because the x comes first, right? It's a hyperbola. I mean, it's a horizontal hyperbola.
I was looking down when you did the blue, I was writing down. So for graph,
I tried to dash my asymptote, but it dashed the graph and not the asymptote. I was just saying make sure you make your asymptotes look different from your rotated axis. That's all, so you don't get confused. Like it literally just made a hole in my graph. It didn't dash the asymptote. Because you're going to rotate it, I just want you to establish the difference between your rotated axis. You're going to draw on 4 lines. You're going to draw on your rotated axis, and then you're going to have to draw your asymptotes. So how do you distinguish between the two was what I was trying to say. And you could dash or make it light, your asymptote, and then make sure that your actual rotated axis is different. That's all. Ready for another one? Yeah, this one. So, example 7, which is much more along the lines of what you'd be tested on. Rotate the axis to eliminate the xy term, write the equation in standard form, and then sketch its graph. So this time, again, we have an xy term, which is what causes the rotation, but this time you have an x squared and a y squared. So before we even start this example, all right, so we're going to start with our angle, right? So the cotangent of 2 theta equals a minus c over b. What is a? A is 13. What is c? C is 7. What is b? 6 root 3. Yuck. Now what? 6 over 6 root 3, which becomes 1 over root 3. Now before we rationalize this, because you've been so programmed to rationalize, remember we're going to flip it to get the tangent. So don't rationalize it. So the tan of 2 theta equals root 3. You with me so far? Yes? If you left it as 1 over root 3, you'd have to rationalize it, but we want to flip it. We don't want to rationalize it. So we flip it, right? Because cotangent becomes tangent, and 1 over root 3 becomes root 3. So what is 2 theta? Where is on my unit circle first quadrant, what we're looking at, is my tangent root 3. Pi over 3. But 2 theta equals pi over 3. So I have to divide by 2, which is multiplying by a half, and I get theta equals pi over 6. Step 1. God bless you. Now we're basing everything off the pi over 6 coordinate point. Do we know that coordinate point off the top of our head? Root 3 over 2, 1/2. You'll have it, don't worry. But somewhere in your brain it should be there. But that's the top. Okay, so remember my x we're replacing with x prime cosine theta minus y prime sine theta. And our y we're replacing with x prime sine theta plus y prime cosine theta. Now we have a lot more x's and y's to replace them with, right? So you're going to want to write this small. See how small I can get it. 13 times my x, which is x prime cosine, and we know theta is now pi over 6, minus y prime sine pi over 6 squared, plus 6 root 3 times my x prime cosine pi over 6, minus y prime sine pi over 6, times the y, x prime sine pi over 6, plus y prime cosine pi over 6, plus 7y squared, x prime sine pi over 6, plus y prime cosine pi over 6 squared, minus 16 equals 0.
You basically just replace those.
Every x gets replaced with that long thing, every y gets replaced with that long thing. Yeah. Yeah. So I'm going to do a couple of things in the next step, but I just want to be really, really clear about it. I'm going to remove the primes for now, but I'm going to remember to put them back in my answer. Without the primes in your answer, you're going to lose points. So I'm going to remove them to make our lives a little bit easier. But I'm going to remember to put them back at the end.
As long as we write the equation with the.
Correct.
Okay.
Yep. And there are 2 binomial squareds there. So I'm going to use the shortcut on this one and on this one.
And then the middle one is
The middle one is a pain in the butt. It's not the difference 2
Oh,
squares.
it's not.
It looks like it is, but it's not.
So you have to do it.
Mm-hmm. Jacob, how are you sleeping through this? This is riveting information. All right, I'm going to start with the first one. So 13 goes on the front. Don't forget it. That's a common mistake. We start to lose things when they get complicated. All the cosine of pi over 6s are going to be root 3 over 2. So that's root 3 over 2. This is root 3 over 2. This is root 3 over 2. And this is root 3 over 2. All the sines of pi over 6, 1/2. 1/2. 1/2. I don't want to rewrite that whole line again, so I'm just going to do this for each one. And then I'm going to put the term after, the variable after the value. So I'm going to do root 3 over 2x minus 1/2 y. Again, I am losing the primes now, but I'm going to bring them back. Plus 6 root 3 over 2x minus 1/2 y times 1/2 x plus root 3 over 2y. Plus 7 1/2 x plus root 3 over 2 y squared minus 16 equals 0. Now again on all the squareds, I'm going to expand that using the shortcut. So this is 13. Shortcut says square root 3 over 2x. Square of root 3 is 3. Square of 2 is 4x squared. Double the product here. So 1 times root 3 would be root 3. 2 times 2 would be 4. So this would be root 3 over 4 times 2. It's negative 2 root 3 over 4 x, y. And I'm going to leave that as over 4, not simplify it, because you're going to see in a moment we're going to get rid of all the fractions. So we might as well keep them the same. And then square the last term, so the square of 1/2 y would be 1/4 y squared.
That's just the first one.
That was just the first one. We didn't even distribute the 13 yet. Yeah. The second one is not a shortcut, so I'm actually going to FOIL it off to the side. Root 3 over 2x minus 1/2 y. Root 3, or sorry, 1/2 x plus root 3 over 2y. FOIL it out. Root 3 over 4 x squared plus 3 over 4 xy minus 1/4 xy minus root 3 over 4 y squared. Root 3 over 4 x squared plus 2/4, and yes, I'm going to keep it as 2/4 because again, I'm going to get rid of those fourths. Root 3 over 4 y squared. And that's the second set. So the 6 root 3 still at the front. Then comes the purple. 7, and this time I can use the shortcut because it's a square. 1/2 x squared is 1/4 x squared. The product here would be root 3 over 4, double it, and it's 2 root 3 over 4 xy plus root 3 over 2 squared is 3 over 4 and then y squared. Minus 16 equals 0.
So you couldn't use the shortcut for the middle one?
Correct. Yeah, they are opposites, but they're not the same. They're the opposite sign, but not the same terms. And it's not squared.
Oh, yeah.
So it either has to be the difference 2 squares or it has to be parentheses squared.
I was stumbled.
All right, here's a good step, right? I'm going to get rid of all those over 4s. Every single fraction that we have built into this equation has an over 4. So if I just multiply each grouping by 4, it's going to get rid of it all. So I'm going to literally multiply everything by 4. Hi. So they're gone from here, they're gone from here, they're gone from here, but I have to multiply this by 4. So fun, right? 13, 3x squared minus 2 root 3 xy plus y squared plus 6 root 3 x squared plus 2xy minus root 3 y squared plus 7x squared plus 2 root 3 xy plus 3y squared minus 64 equals 0. Now what? I can put the 64 on the other side. I'm not going to rewrite that whole sucker though. Just remember to move it, yeah. Then what?
Divide by 64.
Not yet. I have terms on the front of all those parentheses, right? I got to distribute. So distribute, distribute, distribute. 39x squared minus 26 root 3 xy plus 13y squared plus, let me change the color so we differentiate, plus 6 times root 3 would be 6 times 3 or 18x squared. 6 root 3 times 2xy would be 12 root 3 xy. 6 root 3 times negative root 3 is 6 times 3 again, but it's negative, so negative 18 y squared. Then the 7 goes. 7x squared, 14 root 3 xy, 21 y squared, and this time we'll put the 64 on the other side. Now we combine like terms, and if you've done it correct up to this point, your xy terms should eliminate. This is like how you know if you're way off or you're at least on the right track. If your xy terms do not eliminate, then you've done something wrong. So look at your xy's first. I get negative root 26, negative 26 root 3, positive 12 root 3, so I'm at negative 14 root 3, and then positive 14 root 3. So they're gone. So at least we know that part right. Now I group together all my x squareds, so 39 plus 18 plus 7, 64x squared. Group together all the y squareds, 13 minus 18, negative 5, plus 21, positive 16y squared equals 64. Getting closer to standard form, but what do I have to do to get it completely into standard form? Divide everything by 64. X squared over 1 plus y squared over 4 equals 1.
This one's not us.
And before I write that on the line, I have to do what?
Rotate.
Put that prime back in. X prime squared. You don't have to leave it over 1, but you can if you want to. Plus y prime squared over 4 equals 1.
Do we have to keep like the parentheses in this or not?
No, as long as you don't confuse those two or lose one of those two.
Okay.
So tomorrow we will graph that. Okay? My advice is to at least start the process on the homework. I will bump it to Thursday, okay? But at least try one. And I cannot stress this enough. Your project is due tomorrow. So do not forget it, okay?
This one's an ellipse.